In this lesson, we talk about adding and subtracting radical expressions. Adding and subtracting radicals is a lot like adding and subtracting variables, and we follow the rules of algebra. Let us take a look at example 1. What if we are given 2 square root of 3 plus 5 square root of 3? Adding radicals is similar to adding algebraic expressions. So, 2 square root of 3 plus 5 square root of 3 is equal to 7 square root of 3. We think of 2 square root of 3 and 5 square root of 3 as like terms. Both terms have square root of 3. In the case of unlike terms, say 2 square root of 5 and 8 square root of 3, we cannot combine them in a similar way. Remember, when we are adding radicals, we only combine like terms. Now, sometimes we end up with radicals that do not seem to be like terms, but we end up combining the terms anyway. Let us consider example 2. At first, 2 square root of 3 and 4 square root of 12 do not look to be the same. However, square root of 12 is not in simplest form. We rewrite the expression as follows. What we have done is only to factor 12 as 4 times 3. Note that one of the factors is a perfect square, so we end up with this expression, which is also equivalent to this. Now, we have like terms 2 square root of 3 and 8 square root of 3. These terms, when combined, result to 10 square root of 3. Note that rewriting all radicals in simplest form can sometimes result in radicals that can be combined. Let us consider example 3. Notice that square root of 54, square root of 36, and square root of 24 are not in simplest form. We can rewrite these as follows. Also note that 9, 36, and 4 are perfect squares. So we can rewrite the terms as follows. 3 square root of 6 and 2 square root of 6 are like terms. So we can combine these terms as 5 square root of 6 plus 6. Note that 6 is all by itself. In example 4, we are given 10 square root of 80 minus 5 square root of 5. Again, we need to simplify square root of 80. We rewrite 80 as the product of 16 and 5. 16 is a perfect square. Hence, we could rewrite this expression in this manner. This is also equivalent to this expression. Notice that 40 square root of 5 and 5 square root of 5 are like terms. Hence, we can subtract and end up with 35 square root of 5. Example 5 is a little bit tricky. Square root of 1/2 is not in simplest form. We use this property to rewrite the original expression as follows. Simplifying, we get this expression. We rationalize the denominator to end up with this particular expression. Then we find the LCD, which is 2, and rewrite the expression this way. Because the two terms share the same denominator, we can rewrite it into one single fraction. Notice that 2 square root of 2 and negative square root of 2 are like terms. So we end up with square root of 2 all over 2 as our final answer. In example 6, we are given this expression. We rationalize the denominators. We apply this property to be able to rewrite this expression. We find the LCD. Note that since the two terms share the same denominator, we can rewrite these two terms into one single fraction. The sum of the two terms is just 11, square root of 3 plus 3, square root of 11 all over 33. In example 7, we have the square root of 5/3 plus the square root of 5/12. The two terms are not in simplest form. We apply this property and rewrite the original expression this way. Note that 12 can be written as the product of 4 and 3. Simplifying, we end up with this expression. We find the LCD of the two terms. Note that the two terms can be written using a single fraction. 2 square root of 5 and square root of 5 are like terms. Hence, we can combine these terms into 3 square root of 5. We rationalize the denominator. We apply this property. Note that the 3 in the numerator and the 3 in the denominator gets cancelled out. So we end up with square root of 15 all over 2 as the final answer.